Everyone, this is page 775. We're in the Getting Started section of our lesson, Mod 5, Topic 1, Geometry. And we're continuing to talk about the vocabulary words surrounding probabilities and events. So on the previous page, previous two videos, we opened up with the idea of a sample space, of a probability model, and of figuring out like the chance of an outcome happening for a certain type of event occurring. So some vocabulary being thrown at you at the very launch of this video. You need to go back and make sure that you've completed the probability model. So maybe pause right here and then copy down, get the situation. We can answer question 3 on page 775 when you have this. So pause, go back to question 3. Number 3, study the probability model for each spinner and describe each as a uniform probability model or a non-uniform probability model. Note, in a uniform probability model, the probabilities of each outcome are equal, which we saw that in the previous lesson, the previous video here, that uniform are equal. You saw spinner A, the chance of getting a 1 was the same as the chance of getting a 2, as getting a 3, as getting a 4. But in spinner B, the chance of getting a 1 was not the same, not equal probabilities. That would we consider a non-uniform probability model. So let's just put that into sentence form. I'm going to do some writing and I'll read it out loud, but you might want to go ahead and just skip forward a few minutes, or not a minute, like not that far, a few seconds in the video just to kind of see what I wrote, but I'm rephrasing what I just said. So ready? I'm going to write. You write as well. What is spinner A? Is spinner A a uniform or a non-uniform probability model? Okay, maybe you skipped ahead a little bit. Maybe you followed along. Sorry for no audio there, but there it is. Spinner A is a uniform probability model because the chance of getting any outcome is equal to the others. 1 to 2 to 3 to 4, those are all the same outcomes. Why don't you go ahead and write the sentence describing spinner B? I will as well. Skip forward a little bit, like 20 seconds or so, and just see if we wrote the same thing. If not, after that time, update. But you should pause and you should write yourself what you believe spinner B has as a description for its probability model before you see my answer. Okay, ready? Pause, write, skip forward. Okay, maybe you're back, maybe you skip forward a little bit, maybe just follow along as I wrote. Sometimes watching videos, especially educational videos, are good on like 1.5 times speed, or double speed if you're insane. Okay, spinner B is a non-uniform probability model because the chances of getting a specific outcome are not all equal. And if I go back and look at that model, what I want to highlight specifically on the previous page, just as the example of how I know they're not all equal, 3/10 and 2/10. They're not the same fraction versus 3/12 and 3/12. In fact, they're all 3/12. That's the way that we can tell. Are the fractions essentially the same? Where did those fractions come from? We'll go back and watch page 774, but quick hitter, the number of 1s is the same as the number of 2s, is the same as the number of 3s, and is the same as the number of 4s for spinner A. But that's not the case in the sample space for spinner B. The number of 1s is not the same as the number of 2s. So therefore, non-uniform probability. Now we're going to introduce in question 4, going back to page 775, we're going to introduce in question 4 some notation. which was already introduced on the previous page, but now we'll put it into action. Here's how I would read it, but then I'll show you like what symbols and what letters I would use to say what I wrote in math notation. Use your probability models to determine each probability. What is the probability of a spin resulting in a 3 on spinner A? So we need to know two things. We need to know the event, and we need to know the sample space. In the event, I wrote sample space, and my face is in front of that. In the event of getting a 3, but only in the sample space for spinner A. And I can abbreviate this in math notation as probability, so that's the big old capital P, of getting a 3 with spinner A. Well, there is the fraction that came from the probability model, 3/12. Now, mind you, this 3 is the event. This 3 is how many 3s are in the spinner, and there are 3 3s. So these are not meant to be the same. In fact, let's look at 4B just to kind of see a difference, right? What is the probability of a spin not resulting in a 3? And I have some note over on the side that I want to highlight. We're going to use something called the complement of an event. Math vocabulary word not mentioned in the previous 2 pages, but now it pops up when it's necessary. The complement is what's left. So if we have an event of getting a 3, then the complement would be not getting a 3, like getting a 1 or a 2 or a 4. It's all of the outcomes of the sample space that are not outcomes in the event that we're studying. And it's denoted with a little tiny c right up here on the upper right shoulder of the letter or number. So I would write this as the probability, so big old capital P, and a 3, because we want to talk about getting a 3, but the word not will literally be the little c up on the shoulder of the 3. This is, I'm in fact to draw an arrow too in case you pause and you're coming back to it. That not is literally the C, the C in our complement. Well, okay, if there are 3 3s then out of 12, then there are 9 numbers that are not 3 out of the 12 sample space. So we have a fraction, 3/12 for the A and 9/12 for C. Will you do the same thing for 4C and 4D? Will you make sure to write the notation? Will you make sure to write the probability fraction? But you're going to use the sample space of spinner B to do that. Please do 4C and 4D in the next one, okay? Go ahead and pause or skip forward 20 seconds. I'm going to go ahead and keep writing, but you should do the math and then check what I wrote, and we'll come back and compare notes, all right? So here goes 4C and 4D. 3, so I'll go over here. I see 2 tenths, aka 1/5, aka 20%. Okay. Probably spin not resulting. So complement. And that'll be the rest of 2, 8. Okay, 8 tenths, or 4/5, or 80%. Okay. All right. So thank you for skipping ahead, following along, but answering 4C and 4D as well. I guess I'm going to leave you with this question. This is something I want you to wrap your mind around and see if you can provide me with an answer. How does our probability model help us produce the probabilities for the events that we're requesting? I'm requesting that you tell me the probability of getting a 3. How does the probability model help us determine that answer without needing to go look at the sample space, the probability of getting a 3? Do you see the connection between the two? It's even more evident when you consider the complement. How does the sample space, how does the probability model help us determine our answer, requesting what is the probability of a spin not resulting in a 3 on spinner B? I would answer it this way. I would answer it that I know which event I want to have an answer to. I want to know what the probability of getting a 3 is. So the probability of not getting a 3 would be everything else. So I'm going to cover it up. 3/10 plus 2/10 plus 3/10. It'd be the rest of what's there. And I don't need to look at the spinner. I don't need to look at the sample space because I've already done that work. I've already done the work to figure out, okay, I'm not going to count the 3, but I'm going to count all of what's left, all 8 of those options for spinner B. Thank you for watching this this video on page 775. We're going to dive into some sample space in the next activity and a tree diagram and see how a tree diagram is another way to represent the list of all possible outcomes when we look at a sample space for multiple things happening, not just like one spinner and then done. So thank you for watching this video on page 775. Click forward and look at page 776 next. Be ready to learn, be ready to be engaged, and we'll see you in the next episode. Thank you.